to another video lesson on workshop processes. Today we shall be looking at another important process in the fitting shop. The process is metal joining techniques. It is very clear that there are instances whereby we produce separate parts, and these parts are members of a particular assembly. After the production of all these parts, there will be need for one to bring them together in line with the drawing specification, in line with the requirement of the exploded drawing. There will be need for one to assemble the parts. What are the methods to be used in bringing them together? And that is why this topic is very important for one to actually pay attention to. There are several techniques or several methods of joining materials together. But basically, all the methods are classified into two. First and foremost, we talk about the permanent method of joining materials together, permanent method. And the second method is the temporary method. The first method that is permanent, why is it permanent? We are looking at situations whereby the moment the parts are brought together and they are joined, they remain permanent. The only reason that can make us to separate them will bring about damage to the parts, because they have been joined together in a way that makes them to remain one and remain bonded together permanently. For temporary joints, these are joints that create opportunity for one to still separate them after a while, and that gives the name temporary. It is good for assemblies that will not last forever, especially jobs that require frequent maintenance, jobs that require opening and closing up the members together. Such jobs doesn't require permanent type of joining. It requires temporary joints. So, what are the examples of methods that fall under the categories of permanent joint? Very good examples of these are welding, brazing, soldering, and the use of adhesive. So, all these methods fall under the categories of permanent joint. In the process of a permanent joint between parts, it is not possible for one to separate them easily. Separation always brings damage to the parts involved. But these temporary joints, of course, because they are temporary in nature, one can easily dismantle the parts as the case arises. So, permanent joint examples that we have mentioned, we will be talking about the commonest ones among them, which is welding. What is welding? Welding is a process of bringing two similar or dissimilar materials together through the application of heat or without the application of pressure, or with and without the use of a filler metals. I've made mention of two things here: through the application of heat, or without the use of pressure, or through the application of filler metal. We are talking of bringing together two similar or dissimilar metals. If this is iron plus another iron material, the two could be welded together. Iron to iron, we can weld. Steel to steel, we can weld. In the same vein, we can equally weld iron to another iron to brass. We can weld two dissimilar material. So in this case, welding involves permanent joining by the use of heat, and the process involves heating all the mating parts to the level of creating the molten structure, a molten metal of the two mating parts. After which, through the addition of the other material, other filler metal being heated and then create a solidified joint at that particular point. Then a solid joint is formed. There is an example of this that is illustrated in the sketch that I'm showing on the screen. A situation whereby an arc is used to provide the fusion welding. What is an arc? An arc is an electrical energy that creates heat for the purpose of melting the mating parts to be joined. The heat will melt. The part that is being brought together is going to generate that heat to the level of melting the two surfaces. Then the third material, which is the filler metal, is now going to be melted again to fill up any form of cavity that is being created, and after some seconds this is allowed to solidify through the process of cooling. Then the permanent structure is formed. So, and that is that which is illustrated. The arc is being provided by the welding machine, and the energy is transferred through the electrode to the joint to be welded. So the electrode created the arc, and in some cases filler metals may be needed to actually add value to the joint to be created, while in some cases it may not be necessary. So this is a situation of fusion welding. The two surfaces are brought together and they become one. It is a complete permanent structure. They cannot be separated unless the material is to be damaged. What are the type of welding processes that are available, especially for fusion welding that have been illustrated? We are looking at arc welding, which is that which involves the use of an electric arc to generate the heat that is needed to actually melt the metal. While the second type of fusion welding is the resistant welding. The resistant welding creates an electrical resistance. It is very similar to that of the very first example. But how does the electrical resistance, how does it come into play? We have an electrical connection to this one represents the tongue, and a situation whereby I have this one as the electrode, and there is a metal assembly, metal to be welded. Then the lower part equally have this assembly, and we have this mounted to it. This connotes the electrode. This connotes the electrode. And this is the metal to be joined. A to be joined to B. Then the source of the power is from here. Positive, negative. So the electrical resistance is going to be created through this electrode, to these two metals, through the application of pressure. And that pressure will now will create heated spots that will melt this particular spot through the application of this pressure. This portion will be melted and fused together. This has not yet created the arc, as in the case of arc welding. But this is through the application of pressure from here to this bonded portion, through the electrical resistance from the electrode. Then a solid weld of these two members is formed. The top category is the oxy-fuel gas. Oxy-fuel gas. Situation whereby we make use of oxygen and then hydrocarbon fuel, bringing them together. The common example is the oxygen acetylene gas, to create an opportunity for one to weld light material or to do cutting of heavy metals. So another type is the solid state welding, that which involves the process of using pressure alone through the combination of heat and pressure. This is possible for spot welding and some other examples. If it is used, then temperature is below melting point of that particular metal. So these categories of welding process are very common in a fitting workshop, And it is very important for every technician or mechanic to have better understanding of them, for them to be able to apply them whenever the need arises. Then what are the types of joints that are very possible under welding? There are major 5 classes of welding joints. The very first example is the bolt joint. We have the corner joint, then there is the lap joint, there is the T-joint, and there is the edge joint, as illustrated in the diagram that is available in my slide. So, the very first one, labeled A, is the bolt joint, while the one labeled B is the corner joint. The third one, that is C, is the lap joint, while D is the T-joint, and the final one there is the edge joint. These are the common types of joints that are available in welding. The second process under the types of welding method of joining metal, especially the permanent joint, is the bracing. Bracing is a joining process in which filler metal is melted and distributed by capillary action between mating surfaces of the metal being joined together. This is quite different from the normal welding. Bracing does not involve melting of the base metal, but only the filler metal is being melted. Unlike welding, when the base metal will be melted, in this case, the base metal will not be melted, but only the filler metal will be melted. The filler metal temperature in some cases is greater than 450 degrees Celsius, but it's less than the temperature of the base metal. So this is quite different from the normal welding that we have talked about. So the approaches to bracing are being illustrated in the sketch that I'm showing in the slide. You can see a situation whereby the filler metal is being melted onto the base metal that is to be braced, as illustrated here. So in most cases, we had flux and we equally had filler metal. This is already braced joint. This is a the copper assembly that have been braced. So, and this is another bracing process. The filler metal is being melted onto the parent metal. So this is a clear variation from what we know for welding. Welding, the real base metal will be melted, but for bracing, it is not going to be so. Then what advantage does bracing have over welding? Any metal can be joined in the course of bracing, and they can be performed quickly and consistently, permitting high production rate. It is very possible. And multiple joints could be braced simultaneously. It is possible. And of course, we need less heat in the case of bracing. Joint areas that are inaccessible by welding process can also be braced because the process is not that complex. So it is very possible for one to do this. But it is not as if bracing does not have its own limitation. The joint strength is less than that of welding. All braced joints are far, far less in terms of strength to that of welding. And joint strength is likely to be less than the strength of the base metal, because the filler metal that's being used is not as strong as the parent metal. And high surface temperature, if the components that have been braced are going to be operated or used in a very hot environment, definitely the hot environment will weaken the braced joint. So color of bracing material at times may not match the parent metal. These few points are just the limitations that are available for bracing. But aside the limitations, bracings, they are very good method for joining materials in the workshop. And of course, we want to look at where we apply bracing. Bracing is applied in automobile industry, for electrical works. It is equally good for cutting. In mechanical workshop, we use bracing to brace most of the carbide tip tool onto the tool holder. Bracing is applied for us to actually cement them properly onto the tool holder. And of course, in plumbing and heating contractor jobs, HVAC system, HVAC industry, bracing is equally a very effective joining techniques that they employ. Another category of joining techniques that fall under permanent joining techniques is soldering. Soldering is similar to bracing, but in this case, soldering is a process in which a filler metal with lesser temperature than the base metal, they distribute the filler metal by capillary action between the surfaces of the metal to be joined. This is similar to that of a bracing, but like bracing, it doesn't involve the melting of the base metal. It is only the filler metal that wets and combines the base metal to form the bond that is required. So unlike welding too, filler metal is called solder in this case, but in most cases we use soldering for electrical joint. They are very, very relevant in that area. And of course, soldering joints, we have the common ones that make use of the tin and lead, and we have another one that makes use of lead and silver for filling purposes. But one thing is very important in soldering: cleanliness is very key. If the surface to be soldered is not clean, it will weaken the joint that is formed at the end of the day. So it is crucial for one to actually clean the surface of the material to be joined. Processes involved include copper pipe is to be cleaned, then flux is to be added. Then what we need to apply the heat while solder is added. Solder is drawn into the fitting via the heat through capillary action, and the pipe is wiped clean at the end of the day. What can we say are the benefits of making use of flux? Part of the methods, the benefits involved in using flux is to remove any form of oxidation which may want to actually form on the brazed surface. And flux at the same time is equally encouraging cleanliness of the surface to be brazed or the surface to be soldered. Then the illustration I have in the slide I'm projecting shows a typical approach to soldering a joint. There is going to be need for a soldering iron, and there's going to be need for a soldering lead. Soldering lead is the filler metal which is going to be melted on the spot to be soldered. It's a very easy process, but it requires practice for one to actually master the process and follow along. The function of the soldering fluxes that I mentioned the other time: they prevent oxidation, they wet the surface, and they provide cleaning to the surface. Advantage and disadvantage of soldering. Soldering has advantages, and of course it equally has disadvantages. The advantages involve the lower energy than bracing. Then they have capabilities for various heating methods. There's capabilities for various heating methods, and of course it is good for repair works. One can actually employ soldering for repair work. But the disadvantage, the strength of the joint is low. The strength of the joint is low unless that joint is reinforced mechanically again. And of course, joint weakens and then they melt, just like the case for bracing. The joints of soldered joints weakens the more the temperature of the environment increases. So soldered joints weakens as the temperature of the environment rises. This is a very, very clear departure from what we know for welding. But all these that we have talked about fall under the categories of permanent joints. But for the temporary joints, the very common example is the use of mechanical fasteners. Mechanical fasteners. Fasteners come in various types, but the common ones are the use of a bolt and nut, the use of threaded screws, and the use of another example is the rivets, the use of rivets. All these are mechanical fasteners, and they equally find their application in joining materials together. And of importance here is because they are good for situations whereby one needs to open up and then assemble again, open up and assembly, and equally bringing them together for either for the purpose of maintenance or any other purpose. We need temporary joints, and good examples of this are what we find in the use of mechanical fasteners. Examples of bolt and nuts, rivets, and equally threaded screws. These are very good examples. How do we specify threads? The specification of thread is given in the material being provided. Then we can equally go further to look at other fasteners that are available for bringing materials together. Examples of these are the keys. Keys are very good fasteners too. In the working machine, we have shafts that is being installed into another assembly. Shafts in most cases are keyed into an assembly through the use of keys and the keyways. So key is an example of mechanical fasteners, and they are very good methods of joining metals together too. Examples of fasteners are illustrated in my slide that is being provided. Having said this, it is nice for me to recap and go over what we have learned once again. We have talked about methods of joining materials together. We talked about the classification of the method into permanent and temporary. Permanent involve welding, soldering, bracing, and of course, welding, bracing, and soldering. While we equally looked at the use of mechanical fasteners in the case of temporary joint. We have highlighted the advantages, merit, and demerit of each of these methods, and I believe you will have gotten 1 or 2 points from this. And in the course of applying them, by the time you go for the real hands-on, you will see the need to make use of this method and the areas of application for each of these methods. But most importantly, all the 2 methods are very relevant, and we use them based on the kind of need that is applicable to the environment or to the situation or to the work we actually want to apply them to. I'll be talking more about this in our workshop environment. So, thank you for listening.